I use the Vigenère cipher method to encrypt the message. This method uses a polyalphabetic cipher that is based on substitution using multiple substitution alphabets. To encrypt the text, a Vigenère table is used, and the Vigenère cipher is very similar to the Caesar cipher, where the Caesar cipher you pass a single integer as the key. In the Vigenère cipher, a keyword is passed instead. So the Caesar cipher code really helped lay the foundation for the Vigenère code. So the Vigenère table consists of alphabets written out 26 times in different rows. So each alphabet shifted cyclically to the left compared to the previous alphabet, corresponding to the 26 possible Caesar ciphers. So at different points in the encryption process, the cipher uses a different alphabet from the one of the rows. The alphabet used at each point depends on whatever that keyword is because it repeats. That's the whole point, is the repeating keyword. So I altered mine a bit so that it includes some symbols as well, not just simply the alphabet. And to make things simple, the code generates its own key based on the password length. That way the user didn't have to input that. And I also made checks to make sure that the key itself is not longer than the actual plain text, which could cause some errors I found. So using that key and a Vigenère square, the plain text is then encrypted. So here is a quick example. Let me bring this over. So here's a Vigenère square, and here's a message, Pixies at noon, and the key, which is Harry. And so to encrypt this, you would take the key from the top bar, which is H, and you would go down until on the left you've hit the P. And then that P would be replaced with a W. So you go through that process. So here's the message again, Pixies at noon, and the key, Harry. And this is the new cipher, and you'll notice that's a W. Now to decrypt it, you kind of just do the opposite. So you have Harry and you have the W. So you would go to H at the top, you would go down until you hit a W, and then go all the way to the left, and then you would know that would be P. And you just continue that process. So the next letter is A and I. So go to A, go down till you hit an I, and you'll notice it's also an I. And that's how you decrypt the message. Now we'll go to the code and we'll show it working. So here we go. Run. There we go. The lab. We'll do the plain text that was in the lab. Love everyone, treat them kindly too. Forgot the 0. Whoops. And then the password. Okay, then we push enter, and we'll go up. We see all of the code, citations, and right here we'll see the plain text. And then this is the cipher. Here's the table. And then here it is deciphered. And there we go. And that is the Vigenère cipher.
So this is an example of the columnar transposition cipher. Basic concept of this cipher is that you'll take the plain text and a key, and then you'll arrange them in a column in a table such as this with the password at the top. And you just fill it in horizontally. Then in order to get the ciphertext, you will pull out each column alphabetically. For example, E is the first letter alphabetically in the password, so we'll pull out E1, like over here, and we'll pull out TT, and then X exclamation point. And that's how we would get the cipher. In order to undo it, you would use the key to fill in the columns in alphabetical order, and then you could just read it out horizontally. So as an example of it working properly, Let's go recompile it. We have our plain text there. Just grab our password. As you can see, plain text gets scrambled up. And then when we go to decrypt it, it returns it back to the original order. And that is the columnar transposition cipher.